Let's explore the basics of process management, focusing on understanding and managing processes within a Linux environment. We will cover key commands like ps and top, as well as essential process control techniques. So, what exactly is a process? At its core, a process is simply an instance of a running program. Each process has its own dedicated memory space and access to system resources, ensuring that programs can run independently and efficiently. Key characteristics include: first, each process is assigned a unique process identification number, also known as PID, allowing the system to track and manage it. Second, every process is owned by a specific user, which determines the permissions and privileges associated with it. Third, processes consume central processing unit and memory resources as they execute, and monitoring these resources is crucial for system performance. Finally, a process can create or spawn new or child processes, enabling complex tasks to be divided into smaller, manageable units. The ps command is used to display information about the active processes running on a system. By default, it shows processes associated with the current terminal session. Several options are available to enhance its functionality. ps command without any options gives basic process information. psaux command shows all processes with details, and psef command gives a full format listing. On the screen, the first command, ps, shows the process identification number, the terminal type, time, and the command being executed. The second command, psaux, when combined with the head-5 command, shows the first 5 lines of the output, including the user, process identification number, percentage of central processing unit utilization, percentage of memory utilization, virtual memory size, resident set size, terminal, status, start time, time, and command. ps command provides a static snapshot of processes at the moment it is executed, unlike commands that offer real-time monitoring. Let's take a closer look at some common options for the ps command. First, the psaux command. This command displays all processes running on the system, providing detailed information about each process, including the user, process identification number, central processing unit usage, memory usage, virtual size, resident set size, terminal, and command. The second is the psef command. This option provides a full format listing of processes, showing parent-child relationships, user identification number, process identification number, parent process identification number, central processing unit usage, start time, terminal, time, and command. The third is the psu username command. This option allows you to view processes owned by a specific user, providing a focused view of their activity on the system. The fourth is the psppid command. With this option, you can view detailed information about a specific process, identified by its unique process identification number. Now let's break down the output of the psaux command to understand what each column represents. On the screen is a sample output that includes the header and the process listing. Here are some key fields. The user field shows the username of the process owner. The PID field displays the process identification number, a unique identifier for each process. The %CPU field indicates the percentage of central processing unit usage. The %MEM field shows the memory usage percentage. The VSZ field represents the virtual memory size in kilobytes. The RSS field displays the resident set size, which is the physical memory used in kilobytes. The TTY field shows the terminal associated with the process. The STAT field represents the process state code, such as sleeping or running. And finally, the command field displays the command that started the process. Let's explore the different process states, which are indicated by the stat column in the ps command output. R, which stands for running, means the process is either running or ready to run, and is in the run queue. S, which stands for sleeping or interruptible sleep, means the process is waiting for an event to complete. D represents uninterruptible sleep, usually waiting for input or output operations to complete. Z stands for zombie, which means the terminated process is waiting for a parent to collect its exit status. T stands for stopped, meaning the process has been stopped by a job control signal or is being traced. Additional modifiers includes plus sign, which indicates a foreground process group. The small letter S means session leader, and the small letter L means multi-threaded. Now let's explore the top command, which offers real-time process monitoring. Unlike the PS command, top provides a dynamic real-time view of the system's processes. The top command updates automatically every 3 seconds by default. It shows both the system summary and the process list. It is interactive, allowing users to sort, filter, and manage processes. You can press Q to quit and H for help. On the screen, you can see an output that includes the system statistics such as uptime, load average, tasks, central processing unit states, memory usage, and swap usage, as well as a list of processes with details like process identification number, user priority, virtual memory, resident memory, shared memory, status, central processing unit usage, memory usage, time, and command. The top command is highly interactive, offering several keyboard shortcuts to manage and monitor processes in real time. Pressing H displays the help screen with available commands. Pressing Q quits the top command and returns to the terminal. Pressing K allows you to kill a process by prompting for the process identification number and signal. Pressing R lets you renice a process, changing its priority. Pressing F allows you to add or remove fields to display. Pressing U filters processes by user. Pressing P sorts processes by central processing unit usage, which is the default. Pressing M sorts processes by memory usage. Pressing D changes the update interval in seconds. The top command is fully interactive, enabling real-time monitoring and management without leaving the interface. Now let's explore how to filter and find processes using commands like grep and prep. To find processes by name, you can use grep to filter the PSAUX output. For example, PSAUX pipegrep Firefox will list only processes with the name Firefox. To find the process identification number of a specific program, you can use the prep command, such as grep Firefox, which will return the process identification numbers associated with Firefox. To find processes by user, the command PSU username lists all processes owned by a specific user. Also, you can filter top to show only a specific user's processes by using the command top U username. Let's recap the key points of process management in Linux. For viewing processes, PS command provides a static snapshot of processes, PSAUX command shows detailed information for all processes, PSEF command shows full format listing with parent-child relationships, and top command provides real-time interactive process monitoring. For finding processes, PSAUX pipegrep name command filters processes by name, grep name command finds process identification numbers of processes by name, PS U username command shows processes for a specific user, and top U username command monitors processes for a specific user. Key process information includes the process identification number, which is a unique process identifier, the user, which is the owner of the process, the central processing unit or memory usage, which indicates resource usage, the status, which represents the process state, and the command, which is the command that started the process. Finally, the interactive top command allows pressing H for the help screen, pressing Q to quit, pressing P to sort by central processing unit usage, pressing M to sort by memory usage, and pressing K to kill a process. Next, learn about process control with kill, nice, and renice commands. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.